Scatter plots. Scatter plots work very well for showing the relationships between variables. Let's say that we had kind of a classic example is student height, right? And this is where we have shorter students down here on this end, and we progress up through taller students, okay? And over here on the y-axis, we have running speed. And here we have slower students, and here we have faster students. And we assume that our taller students with their taller legs are going to run faster than shorter students with shorter legs. Now, that, of course, is not always true, and there's exceptions, and fitness and other, exercise habits, everything kind of falls into that. But just in these two general ideas, we have a trend that we think is probably going to have a pretty obvious trend, right? We're going to have shorter students down here that move up through, I don't know, this will be perfectly linear. And actually, I have not studied this, so I'm not sure what it looks like. But let's say that it starts to flatten out over time. I have a brother who's really tall, but he is kind of a long, lanky, lopey fellow. So he doesn't run much faster than the people who are half a foot shorter than he is, even though he's ridiculously tall. So we have a graph that looks kind of like this, okay? That's a scatter plot. It clearly shows that we have a relationship, right? We have some kind of there's a curve there. Maybe it actually even curves over more than that. It seems to be flattening out here, right? So we clearly have a relationship. We don't have data over here. We don't have data over here. That would kind of mess up our relationship. And so it clearly shows that we have a pretty solid relationship here. And if we had heights, if we had numbers on here and we said, well, this person is this tall, then we could say, well, if that's the case, we expect them to be able to run this fast, right? So we're clearly demonstrating that there's a relationship here. And I mean, we get a lot of information out of this, right? I mean, we can see that down here in the bottom, we have a tight cluster of points, and generally this happens. Up here at the top at the two extremes, we have a kind of a tight cluster of points, and then it widens out. We have kind of a cigar or a banana-shaped pattern here so that we have more variation in running speed here, and we have less here, and we have less here, right? And again, I have never studied running speed, so I'm kind of making this up. But if these data were real, that would suggest that among short people, the level of fitness or whatever the other factor is that we haven't accounted for here really doesn't do much. Like no matter how much you exercise, if you have short little legs, you aren't going to be able to run very fast, right? And once you get up here, no matter how tall you are on this end, no matter how tall you are, there's just a limit to how fast you can go, right? So you can exercise a lot more, but we only have this short little range, so there's not a whole lot of variation. Down here, though, in the middle, it suggests there's something you can do, right? All of these people are the same height, but we have this wide range of running speeds. And so I would suggest, that people up here on the top are getting more exercise, are more fit, and people down here on the bottom are less fit. Okay, now we haven't measured that in this graph, but it does clearly show that there's more variation in running speeds in the middle than there is in either of the two extremes. So there's a lot of information tied up in this graph. Creating scatter plots in R is very easy. We'll start by opening up our data set. We'll use trees like we have done before. And like always, we'll start by looking at the dimensions of the data set, the names of the variables in the data set, and look at the first few observations so we can begin to see what they look like. We have 31 observations on 3 different variables: girth in inches, height in feet, and volume in cubic feet. And here are what the data look like. To girth, we go to 1/10 of decimal places, and in volume, we're going to tenths of cubic feet, and height is to whole foot integers. Okay? So we can assume that there is a relationship between tree height and tree girth, right? As a tree gets taller, it's also getting rounder. And so we're just going to say with trees,
And again, that just means that whatever comes after that comma inside those parentheses. If I refer to a variable, this just tells R to find them inside the tree's data set, right? So I'm going to plot girth against height. Which it has done. That's not a very tight relationship, is it? Let's look at girth between volume, how round the tree is versus how much lumber it has. Ooh, that's a much tighter relationship. Okay. So we clearly have a tight linear relationship here between these two variables, right? This is just personal preference, but I like it better if the dots are filled in. I think they are easier to see that way. So I'm going to change my point character to 16 instead of the default, and that fills the dots in. But that is all it takes to create a density plot or a scatter plot in R. The variable that comes first, girth, goes along the x-axis, and the variable that you list second goes along the y-axis. But other than that, it is pretty straightforward.